Hi, welcome with Stargazing in the City. You're at the right place if you want to know more about space, stargazing as a hobby, or more complicated stuff such as astrophotography. Now this movie is about the last topic. I kind of want to show and explain how you can do astrophotography in different ways using your telescope, your eyepieces and your camera. And I want to explain how you need to connect all of them. So stay tuned and learn more about astrophotography. The easiest way to start with astrophotography is to just use a camera or even your smartphone and keep it in front of the eyepiece. Now, of course, you need to focus the eyepiece until you get a sharp image, and basically using a smartphone that works best on a bright object such as the moon. But it can still be a little bit fiddly, so just let us take a close look on how that works. If you want to take pictures of the moon or the sun using the proper filters, which I've explained in a previous video, then it really helps if you get an eyepiece such as this one that has an adjustable eye cup. Basically, this is meant to find the optimum spacing from the glass for visual use, because you kind of put your face against this rim. But of course, it is also a very handy, sturdy and horizontal platform to make sure that you get the camera on, or the camera lens on your smartphone exactly above the lens and in the right place and at the right distance. Now there are also several holders available that you can buy, which usually attach to the telescope or to the eyepiece or the eyepiece holder, which kind of do the same thing. They fix the telephone in the proper space above the lens of the eyepiece. Now personally, I never invested in this, because for me, using my telescope visually, I really want to have eyepieces that have adjustable eye cups, because I wear glasses, and that automatically gives me the proper eyepiece to do this type of photography. And this is a really nice and cheap way, because usually you have a smartphone, the investment would be in an eyepiece, but basically that gets you into the field of astrophotography for several tens of euros. When you want to take pictures of much fainter objects deep in space, such as nebulas or galaxies, a smartphone typically doesn't cut it. Simply because either the sensor in the smartphone is not sensitive enough, or because it is practically impossible to keep the shutter on a smartphone open long enough to gather enough light for deep sky astrophotography. So that really brings you into the realm of using cameras such as these, digital SLRs cameras, and attach them to a telescope. Basically, the telescope then becomes the telelens for your camera. So the question then is, how do you really attach a camera like this to an imaging telescope such as this? Most telescopes that are suitable for deep sky astrophotography come with an adapter, typically, that has a specific type of thread at the end. So this one, for instance, is the adapter that gets from 2 inch to 1¼ inch, so that you can use 1¼ inch oculars, eyepieces. But at the end it also has this thread that you can probably see if I move it around. And this is so-called T2 thread, which is something like 42 millimeter diameter hole and a millimeter spacing between the threads. Now there are so-called T2 adapters, such as this one. This is called the T2 ring, that you can then thread onto the adapter. At the other end of this ring there is a so-called bayonet attachment, which is specific for the type of camera that you want to use. This one is a T2 ring that attaches with a Canon EOS bayonet to Canon DSLRs. Now if you look carefully, you can see the red dot on the inside of the ring, which is of course the same as a red dot that is on the body of the camera. So if you put it on and you click it, I now have a Canon DSLR with a nose piece that fits into the focuser of my camera. So if I attach this, and I turn the screws, and that's different for different focusers. You might have 1 screw, you might have 3, but if you connect it securely, then you have the camera attached to your focuser. And of course, if you have the telescope on a mount and you have the camera connected to your computer, you can very precisely focus. In fact, if you use a Batinov mask, like I explained in a different movie, you can of course get perfect focus. Sometimes you might find that even though you connected the camera like I just showed, you cannot reach focus. Typically with refractors, the focal plane is a little bit more to the back with the camera. With Newton telescopes, it oftentimes is more towards the telescope. Now the latter is a bigger problem because you cannot move your focuser more inward than the end of the focus. So either you replace the focuser with a shorter model, or you need to move your mirror up towards the focuser. Both is technically more difficult. With refractors, it simply implies adding an additional adapter piece. This is a 30mm adapter piece that I need to use with this telescope to take photos with my Canon. In my case, I need to unscrew the end, which is the 2-inch holder. Then there's a thread underneath that accepts the supplied extension pieces. And then you turn that one on, you basically extend the focuser tube. At the end of this then comes the original 2-inch holder with the screws, which then of course accepts the adapter with the T-ring, and we're done. So by extending the focuser tube, basically I can now reach focus with my DSLR. Sometimes you want to take pictures of objects in the sky that are really wide and take up a lot of space. If you have a telescope with a somewhat larger focal length, you might not be able to frame that object as a whole in one image. Or sometimes we want to take pictures of faint objects and we want to increase the speed of our telescope. So basically going from f6 to f5 or something like that. In those cases we want to use a reducer, and often for refractors such as these are also combined reducer flatteners, which means that we do not get as much issues with curvature in the image plane. Now most reducers and flatteners have the T2 thread on top, similar to the adapter that came with the telescope. Now this is a 2-inch reducer flattener, which simply goes into the 2-inch holder, and then the T2 ring simply threads onto the top of the reducer, such as this, and then we put the camera on there. So other than adding the reducer and the additional weight, we typically do not need to change a whole lot about the spacing. There is one thing, however, and that is actually the back focus or spacing required behind the lens of the reducer. And that's something that I've talked about before, but that will come back somewhat later in this video. If, like me, you live in an area with a lot of light pollution, but you still want to take deep sky photos, then, well, there are several options. They usually say the best anti-pollution filter is the gas tank of your car, but it's of course not always practical to drive out into, the fields to take pictures. Another way is to use light pollution filters, and there are two shown here. This one is a so-called clip-in filter, specifically meant for Canon APS-C sized sensors, and this is a 2-inch filter. So to start with the latter, the flattener reducer that I showed before has at the end on the telescope side 2-inch thread. So basically you simply take the filter and thread it into the reducer or some other 2-inch adapter that you use, like a diagonal, and now this filter absorbs part of the spectra that come from fluorescent lights, for instance, and that increases the contrast of your images in light polluted skies. The other filter shown here is meant for Canon APS-C sensors like I showed, and basically you just take the filter and it kind of goes into the hole at the end of the body, so to say. And yeah, this similarly takes out specific parts of the spectra and increases your contrast. These type of filters typically also change the color of your image, so basically in post-processing you need to change the balance of the colors to get it right. Also be aware that using these clip-in filters typically means you cannot use all type of lenses or objective lenses anymore, such as the EF lenses no longer fit. So if you want to use such a filter with a normal telephoto lens, check whether or not this filter is compatible. The third and final way to do astrophotography is basically astrophotography. That's a bad word. Anyway, using these type of planetary cameras to make videos of bright objects like the moon, the sun, or planets. This is a CWO ASI 290 MC that I typically use for lunar and planetary photography. Most of these have a 1 1/4 inch tube that straightly goes into your 1 1/4 inch focus holder. But what a lot of people don't realize is that on the inside there's also a T2 thread, like on the focus adapter itself. So you can directly screw these type of cameras on your, focus adapter. And that's a much sturdier way. It doesn't introduce any tilt. So if you have the opportunity to use a T2 connection for these type of cameras, please do so. It's better than using the focuser directly. Now you might think, hold on, if I want to use these cameras with the focal reducer or a flattener, that had a T2 connection, so why not just screw it on directly? Because these cameras actually also allow you to open the shutter for longer time, so you can do deep space photography with these type of cameras. And yeah, it would fit, so the connection is not a problem, but this wouldn't work. And the reason for it is that this reducer requires 55mm of back focus, which means that the sensor needs to be 55mm from the lens inside the reducer. And this is simply not working with this sensor here. So you might not be able to use this specific camera with this reducer. There are, however, different reducers. There are reducers that are more simple. So, for instance, there are simple 2-inch reducers. So this is a 2-inch focal reducer. It's a very simple lens. It's much like a binocular objective lens. And this threads directly onto the 2-inch part of an adapter. And I found out that with my CWO camera I can use this specific adapter threaded onto the T2 side, and now this has the right distance from the focal reducer lens. It's something like 48mm, which works pretty well for a reduction factor of 0.5. And this way I can actually take some useful pictures of deep sky objects that are compact. I will include one of M27 that I've made now. Well, I hope you enjoyed this movie and I hope it was useful. Just to recap, this movie showed how you can use your smartphone or simple camera to make pictures through the eyepiece, how you can use a DSLR camera for deep space photography, and how to attach a planetary camera to actually make movies of the sun, the moon, or bright planets. And it also showed how you can use filters or extension tubes or reducers and Barlows. Now in the next movie I hope to show a little bit more about the results and maybe go outside in the dark and go over a imaging session, for instance. But for now, thanks again for watching and see you next time.